In today's class, we are going to discuss about data compression. So why we are using data compression in multimedia and how it works and what are the different algorithms we are going to use it in data compression techniques, that and all we are going to see in our today's class. So first I am saying data compression. What is the need of this data compression in multimedia? While I'm saying multimedia elements, what are the different multimedia elements we are having? Text, audio, video, images. So while I'm saying this elements of multimedia, it contains a huge amount of storage capacity. So for that, we need some kind of speed up process, or you know, to transfer the file in a speed manner, we need the data compression technique. So how we are going to use the data compression is, in order to manage that large multimedia data objects, we need to be compressed to reduce the file size, and also at the receiver end, it's need to be reconstructed. So the reconstructor is nothing but decompression. Okay, once again, you're going to decompress it. So this is what we are going to use it in the data compression. So next we are going to see about what is called as an data compression. So data compression is nothing but it implies sending or storing smaller number of bits. Although many methods are used for this purpose. In general, these methods can be divided into two broad categories. One is isolate, that is lossless. Another one is lossy method. So see this diagram. It clearly mentioned data compression methods having two categories. One is lossless, another one is lossy methods. In lossless, we are following run length encoding, Huffman, Lempel, then JPEG, MPEG, MP3 for lossy methods. These are the different algorithms we are following in the data compression methods. So what do you call as data compression? So what is the purpose of this data compression? Is nothing but data compression is a reduction in the number of bits needed to represent the data. So what type of data it going to represent is that may be a text or images or video, audio files. So compressing, while I'm saying compressing data can save storage capacity, it also speed up the file transfer, and also it decrease the cost for storage of hardware. Next one, while I'm saying it has two broad categories, lossless and lossy. So we are going to see this lossless and lossy one by one. First, lossless compression. So what you call as a lossless compression is nothing but, see here, lossless compression is not, in lossless data compression, the integrity of the data is preserved. So what you call as preserved is nothing but it's going to save. Here, the original data and the data transfer, that is data after compression and decompression, are exactly the same. That is, here once you are going to compress or decompress, the data remains same only. So why you are saying is because no part of the data is lost in the process. That is what the advantage of the lossless compression. Here we are following the run data. So run data means nothing but repeated data is going to be removed in compression and added during decompression. So let me see this with an algorithm concept. First, for lossless compression, we are following the run length encoding algorithm. So what you call as a run length encoding algorithm is nothing but, in run length encoding can be used to compress data made of any combination of symbols. It can be very efficient if data is represented as zeros and ones. So we are going to compress the data made of any combination of symbols. That is the first point we already mentioned. So what type of symbols it going to include means that may be zeros and ones or else the characters. So while I'm using zeros and ones, it to be a more effective. Okay, that is the second point repeated here. So what is the main theme of this run length encoding? The general idea behind this method is to replace consecutive repeating occurrences of any symbol by giving it in a one occurrence of the symbol followed by the number of occurrences. Instead of repeated occurrences, we are giving only the one occurrence of the symbol. So that is the last point is the same. We are using zeros and ones. It should be more efficient. So when this run length encoding, we will see with an example, then you clearly understand about the concept. See this example, we are following the original data. The original data is given as The original data is given as what? B, A, N, M. So these are the characters. So B, while I'm saying B, the original data, how many times it is repeated? B is repeated first time, second time, third time, 4, 5, 6, 7, 8, 9. So totally B is repeated for how many repeated occurrences? It is repeated for 9 number of occurrences. So what is the main theme of the run length encoding? Going to compress the data. How it going to compress the means? All the repeated occurrences are given in a single occurrence. So here the mean is B only. B is repeated for 9 times. Likewise, we are going to write for the A, N, M. M is repeated how many times in the given example is 16 times. N is repeated as 1 time only. M is 10 times. So let me see with an zeros and ones example. See this, the original data is using, we are giving 0 and 1. So here I'm, how I'm considering means, this all the zeros and ones we consider as 14. And while I'm saying this number, we consider as 4, and this one 0, and this one 12. What I'm doing it in a binary numbers, binary digits, and give it in a binary digits, what will the answer we are getting? 111 for 14 and 4 0 0 1 00 and 0 we are simply having 4 zeros and 12 we are having 1 1 00. So this is what our compressed data in run length encoding of two symbols. Next we are going to see about the lossless, that is a lossy compression methods. That is our another techniques we are using in the, which one means data compression. So data compression, what I'm saying, the first one is lossless, that we see with one example, run length encoding. Here I'm saying lossy compression methods. What are the different file formats we are using? JPEG, MPEG, MP3. These we already see it in the diagram itself. So what you call as lossy compression? While I'm comparing, what I'm saying, I just compare this lossy compression methods with the lossless compression methods. So compared to this lossless compression methods, these methods are very cheaper. They can take only less time and space when it comes to sending millions of bits per second for any images or video. So what are the different techniques we are following in lossy compression method is JPEG, MPEG, and MP3. JPEG is we simply called as an joint photographic export group. While I'm saying MPEG, moving picture export group, MP3, MPEG audio layer 3. So JPEG encoding is used to compress pictures and graphics. MPEG encoding is used to compress video, whereas MP3 for audio compression. So once again repeating from the first, what you are seeing the data compression. Data compression is nothing but mainly used for the reduction for any reduction of data. We are using the data compression. So what are the different methods we are following in the data compression method is lossless and one is lossy. In lossless, what I'm saying, lossless compression mean objective is the original data and the data after compression decompression are exactly the same. Here we are following one algorithm, run length encoding for lossless technique. So what we are going to do in run length encoding is nothing but, in this example, how many times the number of occurrences repeated. So we are going to give it in a single occurrence. That is what the main idea behind the run length encoding process. Lossy compression methods, that is what the last point we had discussed. Lossy compression methods is nothing but we are following different techniques. There is file format techniques, JPEG, MPEG, and MP3. Instead of text and programs, we are following here images, then videos, then audios. This is what the difference between the lossy and lossless. So up to this, we will stop our today's class. Rest of the topics we will see it in the next class. Thank you.